Graphing rational functions, example 3. We're going to go through and factor this. This can definitely be factored, see if we can simplify it. On the top, I can pull out a 2x, and what's left over is 2x plus 1. On the bottom part is already factored for us, which is nice. It saves us a little bit of work. So if you notice, I have a factor that's in common on the top and the bottom, so I can get rid of those. And after simplification, this is what I'm left with. So now that we've simplified, let's go through and find all of our major features. Okay. Because we have a factor that cancels, we're dividing out all of those x's except for whatever makes that piece or that factor that's in common equal to 0. So the factor or the value of x that makes that factor 0 would be -1/2. Now if you can't do that by looking at it or do it in your head, just do a quick little scratch work off to the side and just say 2x plus 1 is equal to 0. Subtract 1 from both sides, and then you can divide by 2. And that's where I'm getting the -1/2 from. Now, to find the corresponding y value of the whole, you can't take that -1/2 and plug it back into the original because you're going to end up dividing by 0, which defeats the purpose. So what you want to do is plug it in to the simplified version. So if I take 1/2 and plug it into this version, then we'll get our corresponding y value. So I'm going to take -1/2 and plug it in, and I'm going to have 2 times -1/2 over -1/2 minus 2. And when I do that, I'm going to get, as my corresponding y value, 2/5. So I know when I draw my hole on the graph, it's just going to be an open circle that we draw to show that there is a missing value there. Okay, the x-intercept is the value of x when y is 0. So I want to look to see what makes the numerator 0. And in this case, it would be 0, 0. For the y-intercept, I want to plug in 0 for my x's and see what my y value is. Well, when I plug in 0 for 2x over x minus 2, I get 0 in the numerator, and 0 over -2 is going to be 0. So I'm also going to have a y-intercept at 0, 0, and when it passes through the origin, it's passing the x and the y-axis at the same time, and that's a special case where both the x and y-intercept are the same. For the horizontal asymptote, we're going to look at the rules. Okay. So the rules say that if the degree of the top and the degree of the bottom are the same, we're going to find the leading coefficients of the top and the bottom and divide them. So if I look at the leading coefficient of the top, it would be 2. If I look at the leading coefficient of the bottom, it would be 1. So my horizontal asymptote is going to be y is equal to 2. My vertical asymptote is going to be, after simplification, what makes the denominator 0. So in that case, it would be x equals 2. So I'm going to put this all together. Again, I'm doing this on a scale of 1. Okay, so we have a whole at -1/2 and 2/5. So it's going to be somewhere in here. We have an x and y intercept at 0. We have a horizontal asymptote at 2. So that's where when we go all the way to the right and all the way to the left, that's where the graph is going to flatten out and level out. And for our vertical asymptote, we have x is equal to 2. Okay, now we graph this on the calculator. We're going to put in on our calculator y is equal to, making sure we put parentheses around the top and the bottom. So I'm going to put 4x squared plus 2x divided by, now here on the bottom I'm going to have to do double parentheses because I have parentheses already down there. So I have 2x plus 1, x minus 2. So that's how you want to put it in on the calculator to make sure the calculator knows exactly what's in the numerator and the denominator. And another thing that I want to mention is always use the original function before it's simplified when you go to graph. So I'll make a note of that. Use original function to graph. What happens is if you don't use that original function and we simplify and we just graph the 2x over x minus 2, you might lose some features that you would see on there if you didn't graph the original. So when you graph this, it's going to come down on the left of x equals 2, and it's going to come and flatten out here. And then on the other side, it's going to go up on the right side as you approach 2 from the right, and then it's going to flatten out here.